Hello students, this is SDsir again from the Temple of Excellence, Vidhyaashram Pre-University College, Mysore. We were discussing the chapter Electrostatic Potential and Capacitance, and this is my fifth session of discussion from this chapter. What do we learn in today's class? A very beautiful, interesting concept called electrostatic shielding. What do we learn next? Two classification of dielectric materials, what we call as polar and non-polar dielectrics. And finally, a very important definition called dielectric constant. So, without any lag of time, we will pitch in to our discussion. Just to have a glance of whatever we studied previous, we studied something called electrostatics of conductors, where we understood why the net electric field inside a conductor should be zero. We understood why electric field is always radial to a surface. And finally, we also understood as to why the net charges at the interior of a conductor should be zero. Now, with all those assets, backups, I will start describing a very beautiful phenomenon, what we call as electrostatic shielding. What is shielding generally, my dear friends? The word shield commonly refers to something called cover or to protect. We are shielding someone, we are protecting someone, we are covering them up. But this is not philosophical shielding, something what we call electrostatic shielding. Then what is this phenomenon? It is a matter of common observation that people have a very bad impact when they stand below a tree or in open space, when there is intense lightning and thunder. Andre ಅತ್ಯಂತವಾದ ಮಿಂಚು ಗುಡುಗು ಇವುಗಳಿದ್ದಾಗ ಯಾರು ಮರದ ಕೆಳಗೆ ನಿಂತಿರ್ತಾರೋ, ಓಪನ್ ಫೀಲ್ಡ್ಗಳಲ್ಲಿ ನಿಂತಿರ್ತಾರೋ ಅಂಥವರು ಸಾವಿಗೀಡಾಗಿರೋದನ್ನ ಕೇಳಿದ್ದೀವಿ. ಏನು ಕಾರಣ ಅದಕ್ಕೆ? What is the reason for that? And mainly, how do I come out of that? That is what we understand in something called electrostatic shielding. The textual definition says it is a process of protecting or covering certain region of space. Process of protecting or covering certain region of space from the influence, from the impact of external strong electric fields. We are protecting certain region of space We are covering certain region of space from the influence, from the disasters of external electric field. ಒಂದು ಜಾಗ ಅಥವಾ ಒಂದು ರೀಜನ್ ಅನ್ನು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡಿನ ಇನ್ಫ್ಲೂಯೆನ್ಸ್, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡಿನ ದುಷ್ಪರಿಣಾಮ, ಇದರಿಂದ ಕಾಪಾಡೋದನ್ನೇ ಎಲೆಕ್ಟ್ರೋಸ್ಟ್ಯಾಟಿಕ್ ಶೀಲ್ಡಿಂಗ್ ಅಂತ ಕರಿತೀವಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, you can see here the shielding is done to prevent damages in devices like galvanometers, ammeters, etc. High current sensitive devices, ಚಿಕ್ಕ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ಕರೆಂಟ್ಗೂ ತುಂಬಾ ಸೆನ್ಸಿಟಿವ್ ಆಗಿರುತ್ತೆ. You have to protect these devices from the influence of strong electric fields. That is what we call electrostatic shielding. Then how is it done? Very simple. I will consider a conductor which is placed in a strong electric field. Electric field create ಮಾಡಬೇಕಾದ್ರೆ you need some charges. So I consider this to be a strong electric field. This is the positive plate, this is the negative plate, and this is the conductor. So a conductor is placed in a region of strong electric field, positive plate, negative plate. Now how do I draw the electric field lines from the positive plate to the negative plate? Illi bandaga the field lines cannot pass through the conductor. Properties ಹೇಳಿದಿವಿ. Why? It is free from charges, so it cannot pass through the conductor. Again, from positive plate to negative plate. Now listen carefully. Conductor na ಏನು ಮಾಡಿದಿವಿ? Strong electric field ಅಲ್ಲಿ ಇಟ್ಟಿದ್ದೀನಿ. Suppose this is a galvanometer or an ammeter. Its function is completely destroyed. It will not perform properly. ಸರಿಯಾಗಿ ಕೆಲಸ ಮಾಡಲ್ಲ. ಯಾಕೆ? Because of the influence of the electric field. This electric field will damage my conductor. Galvanometer ಆಗಿರಬಹುದು, ammeter ಆಗಿರಬಹುದು. So what do? I create a hollow space inside the conductor, a hollow region. This hollow region is called lacuna. Lacuna, Greek word una means region, lack of region, lacuna. So I have created a hollow space, lacuna, inside the conductor. So what is happening inside that lacuna? A hollow region alli ಏನಾಗ್ತಿದೆ? Charges present will be zero because electric field inside is zero. ಈ hollow region ಒಳಗೆ electric field ಇಲ್ಲ. Now I take my galvanometer, place it in the lacuna. Will it get damaged? No. Why? This electric field has no impact or influence in this hollow region. ಅದಕ್ಕೆ ಅದನ್ನ hollow, ಒಳಗಡೆ ಏನು ಇರೋದಿಲ್ಲ. So I am shielding my device. I am protecting my device from the influence of the field. How? By placing it in the lacuna, hollow region. What has happened in that lacuna? There is no electric field. So my galvanometer or ammeter is getting protected. This is what is called electrostatic shielding. Shield ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಕವರ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಏನನ್ನ ಕವರ್ ಮಾಡಿದ್ದೀವಿ? ಸೆನ್ಸಿಟಿವ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ಸ್ಗಳು. ಯಾವುಗದು? ಗ್ಯಾಲ್ವೆನೋಮೀಟರ್ ಆಗಿರಬಹುದು, ಆಮೀಟರ್ ಆಗಿರಬಹುದು. ಯಾವುದರಿಂದ? ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ಸ್ ಇಂದ. ಹಾಗೆ ಒಂದು ಹಾಲೋ ರೀಜನ್ ಅಲ್ಲಿತ್ತು. ಸೊ ವೆರಿ ಸಿಂಪಲ್. ಯು ಹ್ಯಾವ್ ಅಂಡರ್ಸ್ಟುಡ್ the entire process of covering or protecting a certain region of space from what? The influences of a field, electric field, is called electrostatic shielding. That is why when there is intense lightning or thunder, lightning andre eno? Sudden discharge of electric charges. It is advisable, very much advisable, to sit inside a car, inside a bus, rather than standing below a tree or in open field. ಕಾರ್ ಒಳಗಡೆ ಕೂತ್ಕೊಂಡ್ರೆ, ಬಸ್ ಒಳಗಡೆ ಕೂತ್ಕೊಂಡ್ರೆ, ಇಟ್ ಬಿಕಮ್ಸ್ ರೀಜನ್ ಆಫ್ ಹ್ಯಾಲೋ ಸ್ಪೇಸ್, ಲ್ಯಾಕ್ಯುನಾ. To some extent, you can save yourself from lightning or thunder. This is what we call electrostatic shielding. Now, continuing my process of understanding the concepts, again a beautiful concept called dielectrics. We will now first understand what is dielectric and the two types of dielectric materials. ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಅಂದ್ರೇನು ಮತ್ತೆ ಎರಡು ತರದು ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಮೆಟೀರಿಯಲ್ಸ್ ಕಾಮನ್ ಆಗಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಮೀಡಿಯಂ, ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಮೆಟೀರಿಯಲ್. ದೆನ್ ವಾಟ್ ಈಸ್ ದಿಸ್ ಡೈಎಲೆಕ್ಟ್ರಿಕ್? ಇಫ್ ಐ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಿಸ್ ವರ್ಡ್ ಡೈ ಅಂದ್ರೇನು? ಸಾಯೋದು, ಡೆತ್. ವಾಟ್ ಈಸ್ ಡೆಡ್ ಹಿಯರ್? ಡೈ ಎಲೆಕ್ಟ್ರಿಕ್. ಮೇಷ್ಟ್ರಲ್ಲಿ ಏನೋ ಸತ್ತೋಯ್ತು ಅಂತ ಹೇಳಿದ್ರಲ್ಲಪ್ಪ. ಎಲೆಕ್ಟ್ರಿಕ್ ಪ್ರಾಪರ್ಟೀಸ್ ಆರ್ ಡೆಡ್ ಇನ್ ಸರ್ಟನ್ ಮೆಟೀರಿಯಲ್ಸ್ ಅಂಡ್ ದೀಸ್ ಮೆಟೀರಿಯಲ್ಸ್ ಆರ್ ಕಾಲ್ಡ್ ಡೈ ಎಲೆಕ್ಟ್ರಿಕ್ ಮೆಟೀರಿಯಲ್ಸ್. ನೋಡಿ ಎಷ್ಟು ಚೆನ್ನಾಗಿದೆ. ಕೆಲವೊಂದು ಮೆಟೀರಿಯಲ್ಗಳಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಪ್ರಾಪರ್ಟಿಗಳು ಸತ್ತೋಗಿರುತ್ತೆ. ಈ ರೀತಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಪ್ರಾಪರ್ಟಿಗಳನ್ನ ಕಳ್ಕೊಂಡಿರುತ್ತಲ್ಲ, ಆ ಮೆಟೀರಿಯಲ್ಗಳನ್ನ ಡೈ ಎಲೆಕ್ಟ್ರಿಕ್ ಮೆಟೀರಿಯಲ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಡೆತ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಪ್ರಾಪರ್ಟೀಸ್ ಇನ್ ಅ ಮೆಟೀರಿಯಲ್. ಸೊ ಮೈ ಟೆಕ್ಸ್ಚುಯಲ್ ಫ್ರೆಂಡ್ಸ್, ದೇ ರೈಟ್ these are non-conducting materials. Non-conducting andre electrical properties are dead, and these materials have no or negligible number of charges. ನಾವೇನು ಓದ್ತೀವಿ ಅಂದ್ರೆ, if at all there has to be conduction, ಒಂದು ಮೆಟೀರಿಯಲ್ ಕಂಡಕ್ಟ್ ಮಾಡಬೇಕಾದ್ರೆ there has to be large number of mobile charges, freely moving electrons. If there are few localized charges, localized andre onde ಜಾಗದಲ್ಲಿ ಇರೋದು, or absence of electric charges, then conduction is not possible, and such materials is what we call dielectric electric materials, dead materials with respect to electrical properties. So very clearly I have told these are non-conducting materials. ಇವುಗಳಲ್ಲಿ electric phenomenons complete ಆಗಿ ಸತ್ತೋಗಿರುತ್ತೆ. Why? Either there are few charges which may not participate in conduction or absolutely absence of charges. So ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ ಇನ್ಮೇಲೆ they are a type of insulators. They don't conduct. Why? Because they have lost electrical properties. So my basic definition of dielectric material says these are non-conducting materials which have no or negligible number of charges. Now coming to their bifurcations, classifications, they are of two types. One, as you see, non-polar dielectrics, and the other one is polar dielectrics. ಎರಡು ಡೈಎಲೆಕ್ಟ್ರಿಕ್ಗಳೇ. ಈ ನಾನ್ ಪೋಲಾರ್ ಆಗಿರಬಹುದು ಅಥವಾ ಪೋಲಾರ್ ಆಗಿರಬಹುದು, ಎರಡರಲ್ಲೂ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಮಿನಿಮಮ್ ಆಗಿರುತ್ತೆ. Then what is the difference between them? In depth you study in your chemistry with respect to chemical nature. Now we will understand them with respect to their physical nature. Non-polar dielectrics. In such materials follow ಏನು ನಾನ್ ಪೋಲಾರ್ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ಸ್ ಅಂದ್ರೆ ಕ್ಲಿಯರ್ ಆಗಿ ನಮ್ಮ NCERT ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಹೇಳುತ್ತೆ. In such materials the molecules are non-polar. Non-polar dielectrics ಅಲ್ಲಿ there has to be non-polar molecules. ಅಂದ್ರೆ ಏನು non-polar molecules? A non-polar molecule is one where the center of positive charge will coincide with the center of negative charge. Very beautiful. Or in more defined words, a non-polar molecule is one where the center of mass of the positive charge, ನಿಮ್ಮ 11th standard ಅಲ್ಲಿ center of mass ಅಂತ ಓದಿದ್ರಿ. It is the region where the entire mass of the system is concentrated. Non-polar molecule is one where the center of mass of the positive charge will coincide with the center of mass of the negative charge. Andre, consider this example H2, very clearly written here. This is H, this is H, this is the center of mass, and this is the center of mass. They say these are such molecules where the center of mass will coincide. ಏನಾದರೂ ಫಿಸಿಕಲ್ ಮೀನಿಂಗ್, ನೋ ಎಕ್ಸಾಜರೇಷನ್, ಸಿಂಪಲ್ ಆಗಿ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ ಹಿಯರ್ ದೇರ್ ಇಸ್ ನೋ ಡಿಫೈನ್ಡ್ ಆಕ್ಸಿಸ್ ಆಫ್ ರೊಟೇಷನ್ ಬಿಟ್ವೀನ್ ದ ಟೂ ಸೆಂಟರ್ಸ್. ಅಲ್ಲಿ ಟೆಕ್ಸ್ಚುವಲ್ ಆಗಿ ಬರೆದ್ವಿ ಅಷ್ಟೇ, ಸೆಂಟರ್ ಆಫ್ ಮಾಸ್ ಆಫ್ ದಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ coincides with the center of mass of the negative charge anta. Adra artha eno? Very simple. It means there is no defined axis of rotation here. When there is no defined axis of rotation, such molecules cannot have permanent dipole moment. Dipole moment now to recall ಮಾಡ್ಕೊಳ್ಳಿ. Just recall this word dipole moment. Some rotation inside an electric field. Here, permanent rotation cannot happen because there is no fixed axis of rotation. Again, if you see CO2, all the three centers, they are coinciding, because of which I don't have an axis of rotation, because of which they cannot possess permanent dipole moment, and such molecules are non-polar dielectrics. Yes, ಚೆನ್ನಾಗಿದೆ ನೋಡಿ. Non-polar. What are these non-polar dielectrics? They have non-polar molecules, sir. What do you mean by that? That means the center of mass of the positive charge will coincide with the center of mass of the negative charge. Agli bidi, consequence no, sir, no defined axis of rotation. Permanent tirgala, sir. Good. So they don't have permanent dipole moment. Now coming to the next one. Polar dielectrics. Now I only answer, sir. Such materials have polar molecules. Very good. Polar dielectrics, such materials will have polar molecules. So now what are polar molecules? The center of mass of the positive charge will not coincide with the center of mass of the negative charge. Non-polar agiddaga, coincidentally, yes. Here, they do not coincide with the center of negative charge. For example, water, you have H, and oxygen negative. So if you clearly observe here, H and oxygen, which is negative. How do you say that the center of mass is not coinciding? Very clearly, they have a defined bond angle of 105 degrees. So, because of this angle formed, chemistry bond angle and karitira. What happens because of that? There is no coincidence of center of mass. Hagidmele, there is a defined axis of rotation, and because of this, the molecules have permanent dipole moment. Here, the center of mass doesn't coincide. They have a defined bond angle. They have permanent axis of rotation. Hence, they have permanent dipole moment. Molecules of water, HCl, etc. Therefore, when I come to the classification of dielectrics, non-polar constituted of non-polar molecules where the center of mass of the positive charge and negative charge coincide, leading to the absence of the axis of rotation, hence no dipole moment. But whereas it is polar dielectrics, they are framed of polar molecules where the center of mass of the positive and the negative charge don't coincide. They have defined axis of rotation and the molecules have permanent dipole moment. So keep in mind, examly there may be a question on difference. Differentiate between a polar molecule and a non-polar molecule for 2 marks. Definition, next coincidence, then dipole moment, examples. These are the 4 key points you will have to reflect in the exam. Now, slightly absurd concept, a concept which will make you all think to some extent, dielectric polarization. ನೀವು ಟಿವಿನ ಚಾನೆಲ್ಗಳು ಸೆಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಅಥವಾ ನಿಮ್ಮ ಸಿಗ್ನಲ್ಗಳು ಸೆಟ್ ಮಾಡಬೇಕಾದ್ರೆ ದೇರ್ ಇಸ್ ಸಮಥಿಂಗ್ ವಿಚ್ ಇಸ್ ಶೋನ್ ಆಸ್ ಪೋಲರೈಸೇಷನ್ ಎಬಿಲಿಟಿ, ಸಿಗ್ನಲ್ ಸ್ಟ್ರೆಂತ್ ಅಂತ ಅರ್ಥ. In your optics, again beautiful phenomenon you study, polarization of light. ಏನಿದು polarization ಅಂದ್ರೆ? Simple agi, just now you understand, polarization means to suppress or restrict. What is polarization of light? It is a phenomenon where light is made to vibrate in only one plane. Alotira, restricting the vibrations of light in a single plane is what we call as polarization of light. And here it is, dielectric polarization. Now the definition says dipole moment per unit volume of a dielectric material may be what is called a non-polar dielectric or a polar dielectric. Dipole moment per unit volume of the dielectric material, that itself is called dielectric polarization. Adar artha eno? 2 lines I have written there. I read out those lines, but what do you mean by that? Very simple. I consider a dielectric material, one dielectric material in consider madidini. Polar material ಆಗಿರಬಹುದು, non polar dielectric ಆಗಿರಬಹುದು. Now I consider unit volume of this material. Unit volume andre eno? 1 meter cube space. Volume alva? 1 meter cube region of this material. Aur adanne unit volume ant karitidare. That is what is called as unit volume. Out of this dielectric material, I have considered unit volume. And because now I apply an external electric field to this material, ಏನಾಗ್ತಿದೆ? Electric field is applied. Understand, adondu dead electric material. Now electric field in apply ಮಾಡ್ತಿದ್ದಂಗೆ some property of electricity should be seen ಅನ್ನೋದಕ್ಕಿಂತ some property of electricity is now induced in the material. Very beautiful. ನಾನು ಯಾವುದನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೆ? Dielectric material which has dead electric properties. I considered 1 meter cube space, 1 meter cube region of that material. Further, what did I do? I have applied some electric field. It starts dancing. Why? Electric field apply madidini. I have induced some electrical properties in this material. So what is the impact? Now the molecules starts rotating. They experience dipole moment rotations. Why dipole moment is coming into picture? Because I have induced the property of electricity. Gamna itkeli, how much of rotation is happening? Rotation andre dipole moment. Per unit volume of this material, how much of dipole moment is induced, that itself is called dielectric polarization. Nodi, matpuna polarization. I have restricted the dipole moment in the unit volume of the material. I am not considering the dipole moment in the entire region. I have restricted it to certain space, what I have called as unit volume. And that itself is called dielectric polarization. And that dielectric polarization is also called polarization density factor. Now, my dear students, if the strength of the electric field is maximum, the molecules move with a greater speed. Dipole moment will be high. If the strength of the electric field is less, dipole moment is less. Rotations will be less. Therefore, clearly observe this polarization is directly proportional to the strength of the electric field. Whatever you told, polarization density factor, dielectric polarization is directly proportional to E, strength of the electric field. If the field strength is more, polarization is maximum. If the field strength is less, dipole moment, that is polarization, is minimum. Therefore, vector P is directly proportional to vector E. Taking out this proportionality, I have introduced a constant. That constant is named chi, a Greek symbol, what we call as chi, and it is called polarization susceptibility factor. Susceptibility means acceptance. Accepting the dipole moment per unit volume. I am accepting a factor here, susceptibility factor, and this is what is called dielectric polarization. Now, coming to my last topic of discussion in this session, a mathematical topic, again a critical one, something called dielectric constant. To understand what is dielectric constant, represented by the symbol K, I will consider the force between 2 point charges separated by some distance in air or vacuum. There are 2 point charges placed in which medium? Air or vacuum by some distance. How do I calculate the force between them? Very clearly from my Coulomb's law. So what did Coulomb's law say? Fa, force between 2 charges placed in air, is 1 by 4 pi epsilon naught Q1 Q2 by R square. ಇದನ್ನ ಎವಿಡೆಂಟ್ ಆಗಿ ನಿಮ್ಮ ಹಿಂದಿನ ತರಗತಿಗಳಲ್ಲಿ ಓದಿದ್ದೀರಾ? Now I consider the force between the same 2 charges. Same 2-point charges separated by the same distance but in a specific material medium. ಅದೇ 2 ಪಾಯಿಂಟ್ ಚಾರ್ಜಸ್ ಅನ್ನ ಅದೇ ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಸೆಪರೇಟ್ ಮಾಡಿ ಒಂದು ಮೆಟೀರಿಯಲ್ ಮೀಡಿಯಂ ಅಲ್ಲಿ ಪ್ಲೇಸ್ ಮಾಡಿದ್ರೆ ವಾಟ್ ಇಸ್ ದ ಫೋರ್ಸ್ ಬಿಟ್ವೀನ್ ದೆಮ್? epsilon naught is replaced by epsilon. So equation 1, force between two charges placed in air or vacuum. Equation 2, force between the same two charges separated by the same distance in a material medium. Now I divide equation 1 by 2. FA divided by FM. Q1, Q2 by R square gets cancelled. 1 by 4 pi gets cancelled. This becomes the reciprocal denominator alirodrinda epsilon divided by epsilon naught. So what have I done? Equation 1 divided by equation 2, FA divided by FM. So it is epsilon by epsilon naught. And this ratio, epsilon divided by epsilon naught, is called as K. Therefore, what is K? It is the dielectric constant. How do you define K? FA divided by FM. Very clearly I showed FA divided by FM. What was FA? Force between 2-point charges separated by a certain distance in free space. What is FM? Force between the same two charges separated by the same distance but in a material medium. That ratio we always call as K. FA divided by FM. And I've also written the dimensional formula for K. So therefore, this completes the first part of discussion on this chapter. Very beautifully, today we learned something called electrostatic shielding. How shielding helps us to better perform and protect my electrical devices. Dielectric materials may be polar or non-polar materials. We understood polarization density factor and finally the definition of dielectric constant. My dear students, please to remember, there is no alternative for nature and hard work. If you want to succeed, yes, you have to perform, you have to work hard. So please do keep repeating work, work and work with all the things that is taught that will yield you sure success. The next class, I'll come up with a beautiful topic called capacitors. Until then, stay safe. Thank you.